Welcome to our chemistry class. So we have a benzene there, and then C6H6 and the bromine, that is the atomic compound, and then we have the reactants and the product, and then we have to find out the theoretical yield of bromobenzene. And before we find the theoretical yield, we need to find which of the reactants is a limiting reactant. Is it the bromine or it's the benzene? Then one way of doing that is to find the molar mass. So the molar mass is 6 carbon plus 6 hydrogen for benzene. So that gives us 6 bracket. Let's go and find the molar mass for carbon. That is 12. Okay, it's 12 molar mass for carbon. So that will be 6 times 12 plus 6 bracket hydrogen is the molar mass is 1. So that is 1. Okay, then from there we need to add everything. That gives us 78 gram per mole. So for 78 gram per mole, and we have 30 gram of benzene, so it's 30 gram multiplied by 1 mole over 38 gram, and then multiplying that by that gives us 30 mole over 78. So what is it equivalent to? This 0.385, that is mole of benzene. So that is C6H6. The next we find the given amount 65 gram of bromine. So let us find the molar mass first. So bromine, the molar mass Br, 2 of them means that we have 2, which is bromine there is 80 per mole. So that will mean that we have 2 times 80 giving us 160 gram per mole. Now finding out how much we have 65. So that remains 65.0 gram multiplied by 1 mole per 160 gram. So it cancels out, and then you have 65 divided by 160. 65 divided by 160 will give us 0.407 mole. So you can see that we have more bromine than benzene. So because bromine is more, then the benzene is going to be our reactive, our limiting reactant. So the ratio is 1 to 1. Okay, that's why it's more. So if we calculate according to the ratio, if it's more or not, the ratio will determine. So 1 to 1, 0.4 to 0.3, then we are going to consider 0.385 as our limiting limiting reactant. So benzene is our limiting reactant, that is 0.385. The next thing that we do will be, okay, we write in the limiting agent with the limiting amount of moles, and then converting that to our target. Our target is bromobenzene, and then we need to find out that what's the molar mass of bromobenzene. See, 6 times 12 for carbon, 5 times 1 for hydrogen, and then plus bromine. Let's go check from the periodic table. Bromine is 80. So bromine is 80. So that gives us 157 gram per mole. Okay, so check all the molar mass from the periodic table. So what we have right now is let's find out what mole we have. So we have 0.385. Okay, so we want to compare that to mass. Like now we have the mole, so what's the mass? So the mass will be 0.385 multiplied by 157, and then that means that we have 60.45 grams. So that's the theoretical yield. So by theory, if we react 65.08 gram, we should get the answer that we got. So now percentage yield will be, remember B, we have to calculate percentage yield. So percentage yield is going to be actual yield over the theoretical yield. The theoretical yield is the perfect example, but not everything complies with a perfect example. So actual over theory multiplied by 100. So actual yield there is going to be 42.38 gram over, that's the given one, over 60.5. The 42.38 gram is the one that we were given to calculate on B. So that is equivalent to 70%. So we get 70% of what we're supposed to get. So we're getting less. So the reaction is not a perfect one. So homework, you have ethane there, and you have find theoretical yield given 125 gram of other compounds. So go through all the questions and make sure you understand everything. Thank you for watching, and don't forget to subscribe.